Okay. Now, can anybody tell me what is the role of R1 and R2 over here in this circuit? Do you know? Write down your answer in a chat box. What is the aim of this R1 and R2? Anyone know? Write down your answer in a chat box. See, these R1 and R2, they are providing a biasing to the transistor. Okay, what is the aim? They are used to provide a biasing to the transistor. Okay, so here I can say it provides a biasing to the transistor. Okay, that is a function of R1 and R2. Now see, here we have to amplify this signal which is given to this transistor and we want to amplify. Now we you know that for that you have to require the operation of the transistor in an active region. Okay, you have to operate this transistor in an active region. Okay, now this is whatever the biasing applied to the transistor, it is called as a voltage divider biasing. Okay, it is called as a voltage divider biasing. Okay. Okay, now tell me how much voltage you are giving here. See this particular, just a second. See how much voltage you are giving. VCC, it is your 12 volt. Okay, and here the other terminal is grounded. Okay, so how much voltage is come across this R1 and R2? Can anybody tell me? Here you are providing a 12 volt and here you are providing a ground. So how much voltage is coming across R1 and R2? Write down your answer in the chat box. Okay, that you have studied Prem in the class theory session. Okay, biasing means, say for example, here we want to provide a base voltage. So suppose consider that here the VB is there. Okay, consider that here, just a second, I will take another color. Okay, and here consider that here the voltage which you are required. Okay, here the voltage which is available, that is at a base, and I will say that it is a VB voltage. VB. Okay, because here you can say it is a base terminal of the transistor and it is at a ground potential. So voltage across this, it is a VB. Okay, so if I want to calculate the VB, how you can calculate? Already you have studied in the theory session. I think Uwe sir is taking. Okay, Uwe sir is taking this portion. So VB is equal to, can anybody give me this equation? Can I write this equation? Voltage dividing rule. Okay, so can I write VB? Okay, VB is equal to voltage across the resistance R2. So the equation you can write like this: VB is equal to R2 divided by R1 plus R2. Okay, and whatever the total voltage available. So tell me how much total voltage is available? How much total voltage is available? See here, how much total voltage? Give me a reply in the chat box. 12 volt. Okay, so here you have to multiply with a 12 volt. Okay, that way you can get a voltage VB. Okay, now what is the meaning of this biasing voltage? Okay, Prem has asked. Okay, so say for example, consider that here you are giving an input voltage, say for example 0. Okay, if you are providing the V input, say for example 0, but still you are getting a VB, biasing voltage. What is a VB? Biasing voltage, and according to that your base current will be flow. Getting my point? Okay, that is called as amplifying. Okay, why? Here you are providing a V input even 0, but still you are getting a biasing voltage here. Okay, and according to that your base current will be flow. Okay, and hence we can say that this transistor will be operate always in a active region. Okay, the transistor will be operate always in a active region. Okay, so here it is clear that what is the role of these R1 and R2? They are just voltage dividers. Okay, they are providing the voltage biasing. Okay, because the bias voltage is calculated according to the voltage, according to the magnitude of the R1 and R2. Okay, so the R1 and R2 values will be decide the biasing voltage. And as per the biasing voltage, your base current will be flow. Okay, and this RL, it is your load resistance. The RE, that is the resistance connected in a emitter terminal of the transistor. RC, it is a resistance connected in a collector terminal of the transistor. Okay, so that is clear. RC and RE. Okay. Okay. Now here you can see we have connected two capacitors. Just a second. See. This capacitor at the input side and this capacitor at the output side. See here it is connected with the input and this is connected at the output side. So these two capacitors are known as a coupling capacitor. Okay, C for coupling capacitor 1, CC1 is coupling capacitor 1. Okay, just a second, I will write down this. Okay, what is the CC? It is a coupling capacitor. Okay, that is called as a coupling capacitor. So CC1 and CC2 both are known as a coupling capacitor. What is the role of this? It is just used to couple your AC signal to the amplifier. Okay, it is just used to connect your AC input to the amplifier. Okay, it may suppose consider that in an input there is any DC voltage level is there. Okay, so if the DC voltage is given, okay, then it is not given to the transistor. Okay, say for example the signal is a combination of AC plus DC. So DC will not given by this transistor due to this coupling capacitor. So this coupling capacitor is only providing the AC signal. Are you getting? Okay. So that is the function of this coupling capacitor. Okay, because this coupling capacitor is only allows the flow of the AC signal. Okay, what is the CC2? It is called as the output coupling capacitor, CC2. That is also called as a output coupling capacitor. Okay. Again, what is output? If there is any DC component, it will not allow to display. It is allow only the AC output. Okay. So that is the role of the coupling capacitor. So it is just to, we can say, reject the DC signal. CC1 and CC2 both are just used to neglect the DC signals. They only allows the AC signal. CC1 is allow the AC signal in a input, and the CC2 is allow the AC signal in a output. Is it clear up to this? Okay, CC2, say for example, you have amplified the signal by using a transistor, but this amplified signal have a some DC component. So it will not show, it will not come to the CRO because here there is a coupling capacitor is there. Okay, so it is not allow any DC signal in the output. Is it clear? Okay, so we have discussed all things. V in, it is our input voltage. CC1 and CC2 are the coupling capacitor to avoid the DC signal. Okay, R1 and R2, that is a biasing, it is provide the biasing voltage to the transistor. Okay, it will decide the biasing voltage by using this equation. Okay, RC and RA, it is the resistive which are connected in a collector and emitter, we can say respectively. Okay, and RL is our load. Okay, so this up to the, so it is, now we are going to perform this circuit in a simulation, and we will see the output waveform of this circuit. Okay, so this is the basic structure of the circuit diagram. The same structures we are going to draw in a multi-sim online. Okay, so now we are going to the simulation. You should not do anything. You have to just observe. So we are observing to observe the bandwidth. Okay, so first of all, we will see that what is the bandwidth. Okay, so I will explain the bandwidth. Can anybody tell me what is the bandwidth? Can anybody tell me what is the bandwidth? Already you have studied in the classroom. So can you tell me what is the meaning of bandwidth? Have you heard about the lower cutoff frequency and higher cutoff frequency? Give a reply in a chat box at least, so I can just know that all of you are there only. Yes, frequency range. Okay, bandwidth is a frequency range where the amplifier will work. Okay, very good. Okay. It is also right. In a short form, you can write B dot W dot. Okay, it is the frequency difference. So it is a difference in a upper frequency. Okay, minus U for upper and lower frequency. It gives the difference between upper frequency and lower frequency. To understand this bandwidth, just observe this, we can say, this diagram. See here, this diagram you can see. 1 minute. See this diagram. Are you able to see this diagram? Yes or no? Please write down in a chat box. Are you able to see this diagram? Okay, what is on a y-axis? It is the gain of the transistor. Okay, here I have drawn the gain. Okay, this is nothing. It is the gain of the transistor. Okay, and here on the x-axis there is a frequency. So whenever I will plot the graph of gain versus frequency, it is amplifier gain. What is the gain of the amplifier? Can anybody tell me? What is the gain of amplifier? What is the meaning of gain? On the y-axis, gain of amplifier. Okay, it is the output voltage upon input voltage. Have you come across this? Yes or no? Yes, very good, Prem. Okay, so that is called as a gain. Okay, so what I have done here, I have drawn the gain of the amplifier on a y-axis, and on the x-axis there is a frequency. So whenever I will plot this graph, so here we can see there is a two frequency range. So here what is this? Lower cutoff frequency. FL means lower cutoff frequency, and FH is a higher frequency. Okay, so if you will observe that between this lower frequency and higher frequency, you can observe that the gain is remaining a particular range only. Okay, that is the change in only 3 dB. Okay, so it is almost constant. Okay, so in particular range, what happens? Your output, the gain is almost remain the constant, or it is the change is fixed. It is not going to vary very much. Okay, it is not like this. The variation is not very much. Okay, it is not look like this. Okay, so the variation is not so much. So these two frequency is tolerable. Okay, so that is called as a bandwidth. Okay, but suppose consider that now your FL is somewhere here. Suppose your FL is somewhere here, and consider that your FH is somewhere here. Okay, so you will observe that there is a large change in a frequency variation. Sorry, large change in a gain variation. Getting? So that is a, so you cannot allow this large change. Okay, so we have taken this cutoff. Okay, so here there is a cutoff, that is a lower frequency, and here there is a cutoff, that is a higher frequency. That is called as a bandwidth. Okay, so I hope that you are clear about this. What is a bandwidth? Okay, so what we can say that the amplifier can be performed well between these two frequencies. Okay, which frequencies? Lower band frequency and higher band frequency. Okay, and that's why it is called as a bandwidth. Means the frequency range, if it is between this FL and FH, then the amplifier can be performed well. Okay, that is called as a bandwidth. Okay. Okay, so it is clear. Now we are going to the observation table. Okay, so all of you are able to see this observation table? Please give a reply in the chat box. Okay, so all of you have to draw this observation table in your rough note. Okay, draw this observation table. So whenever you are doing a simulation your own, you can enter the reading in this observation table. Okay, so we input, that is a peak to peak value. Okay, so first column is serial number, second is frequency, then the third column is output voltage peak to peak. Then what is this fourth column? Can anybody tell me what is this V output upon V input? What you can say this? Anybody can tell me what is this fourth column? Yes, very good. It is a gain. Yes, Gunjan. Yes, Prem. Okay, so that is called as a gain. And here this is the same gain, but it is in a dB. Okay, 20 log in under log of 20 log of V output upon V input. Okay, so that is your observation table. Okay, so have you just off your videos? Now how you can get this input voltage? So in our simulation, we are adjusting this input voltage. Okay, and here we will take a different readings by changing the frequency. You can take so many readings. So here we have to allow the frequency variation. Say for example, we are starting from 500 hertz. Okay, and then you can increase in a step of 100 hertz. It means like this 500 hertz, 600 hertz, 700 hertz, like this. Okay, and we will measure this output for that particular frequency. Okay, so frequency you have to vary. Okay, and according to that you have to measure the output voltage, and by taking this you can measure the gain, and after that you can convert this gain in a dB. Okay, so I hope that the observation table is clear to all of you. Okay, it is clear. So as I told you, this is called as a gain. What is a dB? dB means decibel. It is your gain. Okay. Okay, so after getting this gain in a dB, 20 logarithm, okay, gain. So once you are getting this gain, you have to draw the one graph like this. Okay, on the x-axis, you have to take a frequency. Okay, that you are varying over here. Say for example, I will take a 500. Okay, then I will take a 600 and so on. Okay, so that frequency you have to take on the y-axis. Okay, and here you have to draw the gain in a dB. Okay, you have to draw this gain in a dB. That you have to take in a dB. Okay, so that much you have to draw in a observation table, and from the observation table you have to draw this graph. Up to it is clear what you are going to do. Okay, you can vary. Suppose, say for example, you want to take 500 steps, so you can directly switch over to the 500 to 1000, 1500, likewise. Okay, and according to that, you can measure the gain. Okay, then I will take a 2000. Okay, then I will take 2500. So you are going to keep on the increase of frequency, and according to that, take the readings. Okay. Okay, so this you have to complete. And your graph will look like the graph which we have discussed. See, your graph is look like 1 minute. How it is look? It is look like this graph. Getting? Okay, your graph is look like this. I hope that everyone is clear about this. Now I'm going to the simulation. So just wait for a minute. I'm going to open this simulation. Okay, just I will pause the screen for a 1 minute. I will open the simulation. Uh, just a second, give me a 1 minute. I'm going to open. Give me 1 minute. Just a second. Okay, now it is visible. Please give me a reply in the chat box. The circuit is visible to all of you? Okay. Okay, so here you can see the same circuit we have which we have drawn. Okay, the value of the capacitor, each and everything will be remain same, which already we have discussed in a theory. Okay, the in a word file which I have shown to you. Okay, so here you can see that there is a capacitor C1 and C2, that are the coupling capacitor. Okay, this is our input voltage. That is our load resistor. R3 is our load resistor, and across this we are getting a output voltage V out, and that is our VCC. Okay, and as I told you, here we are getting a in means here we are getting a biasing voltage. Okay, across this R2 we are getting a biasing voltage. Okay, and this is our input voltage. So here you can change the frequency. Okay, here you can see you can change the frequency. So here VPP, this V input shows peak to peak voltage, RMS voltage, average voltage, okay, and the frequency at a particular voltage. Okay. Okay, sorry, here it is written RL, it should be RC, okay. The resistance connected in a collector terminal. So let us, I will give a name RC. Okay, so here there is a RC is there. Okay, and see this VCC. Okay, so here you can see there is a common volt supply is there. Okay, VCC. So this is the VCC is given here 12 volt. Okay, so it will be directly connected, and you can vary the voltage by just clicking on this. Okay, you can increase the voltage in a multiplication of 0.1. You can increase the voltage in a multiplication of 10. Okay, so that is our VCC. Okay, so circuit is clear to all of you. What are the different parts of this circuit diagram? Yes or no? Up to this, it is clear. Write down in a chat box. Okay, now see, first of all, as per the observation table, what we require? We require input voltage, okay, and the variation in a frequency we want to give. Okay, just a second, I will say at the screen, what is our observation table? Okay, so this is our observation table. Okay, so input voltage, that is we require, and the frequency variation we want to give. So how we can apply in this particular circuit diagram? Okay, so just click on this source of the input voltage. Okay, so when you click on this, you can see here right hand side. Are you able to see the right hand side? How I can get? Just click on this voltage source, and right hand side you can see this. Okay, so here how much frequency is there? You can see in here. See, the input voltage is 10 millivolt. Okay, input voltage is 10 millivolt peak to peak. Here it is written peak voltage. Okay, getting or not? And what is the frequency you can see here? Give me the answer. What is the frequency you can see over here at the right hand side? Give an answer, that's I can know that all of you are here only. Otherwise, I will ask to the particular person. Yes, Rushi, very good. It is a 10K. Okay. But as I told you, we will start with a 500 hertz. Okay. So let us, I will change this. Okay. And I will start with a 500. Okay. So when I will click on this, here you can see the frequency will be changed. Yes or no? What is the input voltage? 10 millivolt. And what is the frequency? 500 hertz. Okay. So that we have seen. We have adjusted input voltage peak to peak. Okay, that is our input voltage peak to peak, 10 volt. So what you will write in observation table? Just a second. In this observation table, what you are going to write? The first reading, here you write peak to peak voltage 10 millivolt and the frequency is 500 hertz. Okay, now let us, we will do, come to our circuit diagram. Okay, so now what we will do, we will take a output because we require a output voltage now. So what you have to do here in a green panel, you can see the interactive. You have to go in a transient. Okay, and then you have to run. See here, there is a run arrow is there, triangle. Okay, so just a second, you are getting the graph like this. Yes or no? You are getting a graph like this. Okay, now see, just a second. So this is our input voltage, 10 millivolt. Are you getting this blue one? It is our input voltage. See, I have just tick input voltage and that green one, it is your output voltage. See, this green one is output voltage. How you can get? See, whatever you tick mark over here, according to that you will get. Only you require input voltage. Just click on the input. So that is our 10 millivolt input is there. You require only the output voltage, then tick mark over here, you are getting only output voltage. If you want both in a same graph, then you have to take both. Is it clear? Okay. Okay, now here, see, you can change the y-axis, okay, because if you want to change, you can also change, okay. How you can change? You can see over here, if you will scroll on, you can get a voltage minimum. So here minus 300 volt written. You can change it. You can say minus 600 minus 60. Okay, and maximum that is a plus 60. Okay. So here you can see. Okay, so you can get a graph like this. Getting or not? Okay, why I have to do this? You can zoom it and you can pick the peak value of this input voltage. It is your input voltage. Okay, so you can pick the peak value. You can just scroll on. Okay, like this. You can just, so you are getting a different values at a different second. Okay, say for exactly 4 second. See here, there is a 4 second is there. You can see at a 4 second how much voltage is there. You can see that at a 4.5 second how much voltage is there and so on. Are you getting? Yes or no? Please give a reply. Are you getting this? Okay. Now see, same way we can go for a output signal. Okay, but see, my output voltage is beyond the 60 millivolt. Okay, so again I will what I will. Okay, it is a larger one. So again I have to change. So say for example, I will say minus 300. You have to just see that it is visible or not. If it is not visible, you can change the range. Okay, so here you can see your graph. So here you can see at approximately 1 millisecond, the voltage is 250.39. Okay, so if you put your cursor according to that, you are getting a different value for a different seconds. Okay, so that you have to note down for a different time like this. Okay, so if you want to find out the peak value, just go in a peak. Okay, so you can say what is the peak value of this graph? Give me a reply in a chat box. What is the peak value you can see over here? Approximately 250.39. Yes or no? See, I have put this cursor on a peak value 259.31. Okay, so that is your peak value. Okay, so how you can find out the gain? So say for example, I will draw the both. Okay, so how you can find out the, so first of all, you have to find out the peak of the input voltage. So the input voltage peak is 9.98 and the output voltage peak is 255.39. So output voltage divided by input voltage. So 250.39 divided by what is the peak? Just scroll on. So 9.90 whatever. Okay, 9.98. So that is you are getting a gain. Output voltage upon input voltage. So roughly I can say at present how much I gain required. So it is 9.98. It is means approximately 10. Okay, and my maximum value is 250. So 250 divided by 10. Okay, so roughly I'm getting a 25. Okay, so my gain is approximately 25 for this case. See, input voltage maximum, sorry, output voltage maximum. The green one, it is a graph of output voltage. So output voltage is 255.39 maximum and the input voltage is 9.98, so it is approximately 10. So 250 divided by 10. So my gain is 25. Okay, is it clear? Okay, so now I can say that by changing this frequency, you can find out the different readings. Okay, you have to change this frequency. How you can change? Click on this and change the frequency. Okay. And we will draw the curve. Now I will change the frequency, say for example 1000. Okay, so now we have given a 1000. Now again I will run. Okay, so this is a graph. Okay. Okay, so here I will change the range because my output is going outside. So say for example, I am setting 500. Okay, so you can see the output. Okay, so this is the output. What is the maximum voltage? Output voltage 403.19. And what is the maximum input? That is the fixed. That is a 10 volt approximate. Okay, because we have adjusted 9.9849, means approximately it is a 10 volt maximum input voltage, and our maximum output voltage is approximately 403.19. So 403.19 divided by 10, we are getting it a particular gain. Okay, but it is at a frequency 1000 we have adjusted. Okay, so if you will do by changing this frequency in our, we can say in our circuit diagram, you can find out the different readings. Okay, so for example, just a second, I will show you the my readings which I have taken. For 1 minute, I will pause the screen. One minute, I will show you. Okay, so for your reference, I have seen the taken the different frequency. Okay, so are you able to see these experiment results? Yes or no? Give a reply in a chat box. Okay, so here you can see that here I have taken a frequency 50, 100, 300, 500, 700 like this. And I have changed the input, I have fixed the input voltage 0.02. Okay, I have keep the voltage constant, input voltage, and your output voltage will be very high because your frequency is vary. So your output voltage will be vary. You are getting the output voltage. Okay, and after that I have taken a gain. The A is nothing, it is a gain. That is nothing, output voltage upon input voltage. So you are getting this, that you have to calculate. So what you have to do in the circuit diagram, you have to change the frequency. You have to fix your input voltage at any one point. Okay, you can take a 0.03 or you can say 0.04, whatever. But once you are fixing your input voltage, only change the frequency and see whatever the output voltage you are getting. Take a ratio of output upon input and then take a 20 log of this reading. 20 log 3.099. So you are getting this answer. Is it clear? Yes or no? Getting yes or no? None, then yes. What about others? All of you are getting what I have shown you? Okay. And if I will plot a graph, the graph is look like this. See on the x-axis 50, 100, 300. This is the frequency. And here there is a dB. Okay. So the graph name is dB versus frequency. And you are getting a graph like this. Okay. Is it clear to all of you? Now see, this circuit diagram you have to do your own. Now how you can do, just concentrate over here. Just a second. Okay, now how you can develop this circuit diagram? So what you have to do? Okay, so just for for all of you, just I will show that in a online, you have to just open the Google. I will show you. Okay, open the Google. Are all of you able to see that I have opened this Google? Yes or no? Please give a reply in the chat box. Okay, and that you have to search multi-SIM online. You have to write down multi-SIM online. It is free. Okay, so you can also do with a mobile also and your laptop also. Okay, so just search a multi-SIM online. Okay, once you are click on this multi-SIM online, it shows a multi-SIM live online circuit simulator. So click on this. Okay, so whenever you will click on this, you are getting this type of page. All of you are able to see this page, please give a reply. So here there is a login is there. So if you have already the login, then you have to click on a login. But if you are new, okay, if you have તમારી પાસે જો એનું login જ ન કરેલું હોય, never in a multi sim live, then you have to go in a sign up. Okay, and you have to fill up some details. Okay, you have to fill up some details. I will show you. So you have to write down your name. Okay, then you have to write down your first name, last name. Okay, then you can write down your roll number. Company, you can write down your Marwadi University. You have to write down your email address, city, okay, postal code, etc., and your email address and your password, and you can create an account. Okay, so after filling all these details, you can create your account. So once your account is opened, you can see this type of page. This type of page. Once your account is open, and then directly you can go in a login. Okay, then directly you can go in a login. Okay, my is already there. Okay, so I can log in like this. You can see. So you can see it is open. Okay, so this type of page will be open. Okay, then you can go in a circuits or create a circuit. Here you can see there is a create circuit is there. Click on this create circuit. Okay, so the same page where I have display. See where I have display here. Okay, so the same page is open now. Yes or no? Okay, so here there are different type of symbols are there. You can just bring and brought like this. Okay, you can bring like this. Okay, say for example, you require a transistor, you can bring like this. Getting or not? Please give a reply in the chat box. Okay, so I told you that how you can open. So just in a Google, write down the multi-sim online. Okay, once you will open that page, the symbol is on login or sign up. As you are a new user, you have to sign up, you have to fill up some your details. You have to set your password, and after that you can log in. Once you will log in, there is a shown create circuit. Okay, and you can just click on the create circuit and you can do your own circuit. And you have to draw the circuit like this. Okay, you have to draw the circuit like this. I hope that everyone has. Okay, so you can do in your in your mobile. So I will give you 10 or 15 minutes to do this. Okay, just try on your mobile. Okay, you can just do the multi-sim online and sign up. Okay, and just find out this page. Okay, Pranav, very good. Pranav has done. If anybody have done, please give it so I can share your also. Okay, anyone has done, so I allow to share the screen of your mobile so other can see that how it is looks. Pranav, if you have done, then can I allow to share your screen so other can see that how it is looks in a mobile? Or is there anyone who is getting in a mobile, whatever this? Please give a reply in a chat box so I can allow, I will make him, I will allow for the screen sharing. Is there anyone? Yes, Pranav. So can I allow you to share the screen? Yes or no? Okay, so I will allow to share the screen, Pranav. So just show me your screen. Can I do, Pranav? Please give a reply quickly. Okay. Okay, no issue, Pranav. You have logged in, it is okay. But just I want to see that this page is, all of you are getting this page or not. It is okay that you have not drawn the circuit. But once you can log in, okay. So I will allow to share the screen. Okay, 1 minute. One minute, huh? Pranav, I have make you host. Are you getting, Pranav? So you can share the screen. Pranav, please give a reply. Okay, I am going to make you host. Okay, so now you can share the screen. Now you can share the screen. Yes, now see, all of you are able to see the screen of Pranav. All of you are able to see? Okay. So see over here, Pranav has logged in. Okay, Bhavya, very good. I think your password is, you forgot your password. Okay, now see, Pranav, you have already logged in. Okay, now see, the initializing of multi-sim is visible to all of you. Okay, it is a Pranav screen. Okay, so here you can see there is a schematics. Okay, just click on the schematics. Yes. Okay, now you can just pick up 2 to 3. Okay, so that way you can do. All of you are getting yes or no? Yes, you can see the transistor NP and PNP, different transistor. Okay, voltages, resistors. Okay, so that way you have to open. So I hope that everyone understand. Okay, and everyone do this circuit diagram in multisim online, your own. Okay, and you will find out the graph which I have shown. Okay, so thank you, Pranav. Make me host. Pranav. Pranav, you can just right click on my name and you can make me host. Yes, thank you. Okay, thank you. Okay, so let us, I will share my screen. Okay, so now all of you are able to see my screen. Common emitter BJT amplifier. Okay, so this diagram all of you have to draw. You can take a snapshot, okay, of this diagram, or after that you can also refer this video. Both are okay, but if you want to do quickly, just take a snapshot of this circuit diagram and try to draw on your own, okay, and find out the results. Okay, you can go in a grapher, you can get a graph. Let's half graph. What is the meaning of half graph and half circuit diagram? You can see. Okay, both you can see simultaneously. Schematic means only the diagram you can see. Grapher means only the graph, means output you can see. And split means you can both. You are able to both. You can draw the schematics as well as you are able to visualize the graph also. Okay, and here what you have to do to find out the readings, you have to click on this. We click and then run by this arrow. Okay, so your results will be displayed like this. Getting? Okay. So here I will complete this practical. That is the experiment number 9. Okay. Sorry. Okay. This is the experiment number 8. Okay. Now let us, we will switch over to the experiment number 9. Okay. Now let us, we will move to the experiment number 9. Just a second. I will pause the screen. Okay, so now all of you are able to see the experiment number 9 on the screen. Give me a reply. Yes or no, please write down in the chat box. Now you are able to see the experiment number 9. Okay, Rushi. Okay, so just read the aim of the experiment number 9. Okay, the aim of the experiment is to design and verify the performance of op-amp as an inverting amplifier. Okay, so what we are doing over here, we are using the op-amp, and how we are using the op-amp as an inverting amplifier, and we want to see, we want to design it, this the op-amp as an inverting amplifier. So we want to design this circuit diagram and we will verify it. Okay, so that is our aim. Okay, these are the apparatus we require. Okay, and that is our circuit diagram. The Uwe sir has told me that this topic is already covered in your classroom. Okay, operation amplifier as an inverting op-amp as inverting amplifier, it is completed in your classroom. Yes or no? Okay, yes, Sandeep. So I hope that everyone know that what the working of it. Op-amp, yes, op-amp you can use as a inverting amplifier or we can say non-inverting amplifier. Both you can use. Okay, either you can use op-amp as a non-inverting amplifier or inverting amplifier, because we know that the op-amp have two terminals. Okay, here you can see. Okay, one we can say the input is inverting input and non-inverting input. Okay, so let us, we will discuss the circuit diagram. Yes, definitely. What we are going to see over here, how the output is amplifying. Okay, say for example, your signal is weak. So how it is amplified and how it is low. That means we want to verify the performance of the operational amplifier. Okay, so we will take a various input signal and we will just cross check it. Okay. So this is our circuit diagram. So that is the input Vi and it is our output. Okay. What is the name of this input? Negative means? Can anybody tell me negative means? What is the another name you can say? See here, op-amp have a three terminals. Okay, here the symbol is negative, positive, and that is one. But what is the another name of this negative terminal? Inverting. Very good, Prem. Okay, and what is the name of this plus terminal? Yes, it is the non-inverting. Okay, generally, if we will see that this pin number is represented as a this inverting is just a pin number 2. This non-inverting it displays a pin number 3, and this output it is just displays a pin number 6. Okay, but here for this diagram we have only three pin terminals. Pin number 2, that is inverting, pin number 3, that is the inverting, non-inverting, and the output, that is the pin number 6. Okay, so just we are using this 3. Which 2 pin I have to show here? For the supply, yes, for the supply I have to show that I can show like this. Just a second, I will draw this diagram. Notepad. I can draw this diagram. Okay, that is my pin number 2. Okay, that is my pin number 3. That is my pin number 6, and other 2 for the supply. Okay, so it should be like this. Here 2 for the supply. This is the pin number 4. Okay, and that is your pin number 7. Like this. At a pin number 4, we are giving a negative supply. So you can connect a battery like this. Okay. At a pin number 4, we are giving a negative. So just I will show you. Okay. The negative of the battery is connected and it is grounded like this. Okay. At a pin number 7, we are giving a positive supply. So consider that is a positive terminal, negative terminal, likewise. Okay, and here its negative terminal is connected with a ground. Like this. Okay. Okay. Now here we are discussing about the inverting amplifier. Okay. So what does mean? So your input must be connected to the pin number 2 or 3. Here we are discussing about inverting amplifier. So your input should be connected with a pin number 2, means inverting point. Okay. If you are using a non-inverting, means your input has to be connected with a pin number 3. Okay. But here we are discussing about the operational amplifier as an inverting amplifier. So that's why we have to connect this input at a inverting pin. Okay. Through a resistance R1 we are connecting. Okay, and this R2, it is also, what is another name? Maybe in a theory you have given him RF, feedback resistor. Okay, why? Because from the pin number 6, the R2 is connected to the pin number 2. Okay, so that is also called as a feedback resistor. Okay, here I have given a name R2, but you can give a name as a RF, feedback resistor. Okay, because from the output it is connected to the pin number 2. Okay. It means we can say that this R2 is making the feedback connection of output to the input. Okay. Okay, up to it is clear. So now what is the closed loop gain of this circuit? Can anybody tell me? What is the, see, this is a feedback path. Okay. So what is a closed loop gain of this circuit? We can say closed loop feedback, closed loop gain. It is given by R2 to R1, and that is a minus. Okay. That is the formula to design this type of amplifier. So closed loop gain is equal to minus R2 upon R1. Okay, so how to select this R2 and R1? So according to your requirement of the gain, you can select this R2 and R1. Okay, say for example, I need a gain of 5. So if I require a gain of 5, so according to that, I have to select R2 and R1. Say for example, I will select R1 is 10 kilo ohm, say for example. Okay, say for example, I'm selecting R. So what's the value of R2? So what should I have to keep the value of R2? I need a gain of 5. I need a gain of 5. Okay, so what should be the value of R2? I have to select. Give a reply in the chat box. Yes, it is a 50. Okay, because see, gain is 5. Okay, and see, we have to just concern with the magnitude. Okay, so I'm writing in a mode. So R2 upon R1. Okay, so I can say R2 is equal to 5 into R1. Okay, so 50 kilo ohm. I need 50 kilo ohm. Okay, so you have selected the R1 and R2 in a such a way that you can get a gain of 5. Okay. Okay, so now what to do? The same thing. Again, you have to open the multi-sim online. Okay, we want to design the same circuit diagram. We will take R1 is equal to 10 kilo ohm, R2 is equal to 50 kilo ohm. Okay. And which readings you have to take? So just a second, I will share with the readings, observation table. So here you can see, this is your observation table. Okay. First of all, you have to select the supply frequency. What is your value of R1? What is the value of R2? Okay, and you have to take a different reading. V in, V out according to that, and gain. Say for example, I will say R1 is equal to 10 ohm. Okay, R1 is equal to 10 kilo ohm, R2 is 50 kilo ohm. Okay, and supply frequency I will keep 1 kilohertz. We are not going to change the supply frequency. We are keeping the supply frequency constant. What we will do? We will change the input voltage. We will change the input voltage. Say for example, first of all, I will give the input voltage 10 millivolt. Okay, then 15 millivolt, 20 millivolt, 25 millivolt, 30 millivolt, like this. Okay, so here we are going to change the input voltage. 10 millivolt, 15 millivolt, 20 millivolt, 25 and 50 millivolt. Okay, so start from the 10. Okay, say for example, it is 10 millivolt. Okay, 15 millivolt, 25, and say 30. Okay, and according to that, you have to measure what is your output voltage by using a circuit diagram. And after that, you are getting a gain. Okay, so that you can check the output voltage by doing a simulation. And once you are getting the output voltage in a simulation, you can measure the gain. Okay. Now draw the observation table in your rough note quickly. We have 20 minutes and we want to complete this. Okay. So draw this draw this observation table quickly in your rough note. Okay, so here I am going to draw the circuit diagram on an online simulink. 1 minute. Okay, I hope that everyone has drawn this observation table. Please give me a reply, yes or no. All of you have drawn this observation table. Write down the supply frequency is 1 kilohertz. R1 is equal to 10 kilo ohm and R2 is 50 kilo ohm. Okay, and this is the input voltage. We are varying. Okay, now let us, I am going to open. Okay, now let us, I'm going to open my online simulation. Okay, now let us, I will do. Okay, I will open my new circuit diagram. I will just open the, I will close all this. Okay, I will show you. Okay, so I hope that all of you are able to see the Google. Okay, I will write down multi-sim online. I will click on this. I have already my account. Okay, so I'm directly go in a create circuit. Okay, so this page is looked with me. Now here you can see there is a op-amp. So I will just take it here. But I require with this one, 5 terminal. Okay, I require 5 terminal. Okay, I will delete this. Okay, how you can get, just click on this, you are getting the another options, 3 terminal op-amp, 5 terminal op-amp, 555 timer, etc. Okay, so select this 5 terminal op-amp like this. Now as per the circuit diagram, we will connect which terminal to the ground. See, this is our non-inverting terminal. So here we are going for a inverting amplifier. Okay, so our non-inverting terminal is connected to the ground. Okay, so I will take a ground. Okay, and I will connect. I will connect it with a. Okay, so I have connected non-inverting terminal. Okay, now here I want to give a supply. sources. So I will take a DC voltage. Okay. Now I will give a DC voltage to this terminal, positive terminal. Okay. So that is my V1, and I will connect. Again, I will take a source. Click on this DC source, and that I'm connecting here. Okay. Now we connect this to the ground. I hope everyone is getting this. Okay. Same way, I will take another ground and I will connect here. Like this. Okay. So is it clear up to this circuit? Yes or no? I have drawn. Please give a reply in a chat box. Okay, Sandeep. What about others? All of you are getting this? Okay. Okay, Khushi. Now we have to take a two resistor, one R1 and one R2. Okay. I am taking a two resistor. And another resistor. Okay. Now I will connect a R1 and R2. Okay, so R1 is connected to the non-inverting terminal. So I will connect. Okay, and we have to connect a feedback resistor. R2 is also known as a feedback resistor. So I will connect here in a feedback. So connect like this. And it is given to the output. So just a second, I will take it somewhat far. Okay, and now I will connect this R2 at the out. And you can. Okay, completed? Yes or no? Getting? Now we require an input voltage source. Okay, so go in an input voltage source. Okay, and also we can connect to this R1. Okay, so here I will connect to the R1. Okay, sorry. Okay. Now here this is should be the source is connected to the ground. So I will take a ground. Okay. And you can connect it. Okay, you can connect like this and just double click. You can escape. Okay. So this is our diagram is completed. Now frequency we have already keep a 1 kilohertz. Okay, and voltage I will take a 0.01 volt. So just click on this. So here you can change the value 0.01. Okay. Now what is the value of R1 we have selected? So see what is the value of the R1 we have? 10K. Okay, so here I will change the value. It is my 10K. Okay, and the value of the R2 is 50K. Okay, so here I will change the value. Sorry, 50 kilo ohm. Okay, so just a second. 50. Okay, so okay, so here R1 is 10 kilo ohm, R2 is 50 kilo ohm. The voltage we have adjusted at a 0.01 volt. The frequency is 1 kilohertz. Okay, so up to it is clear to all of you. Okay, so 0.01 means I have taken a 10 millivolt here. So I hope that everyone is clear. Okay. Now the supply voltage at a pin number 7, that we will take a 12 volt. So here you can write 12 volt. Okay. So your V1 is 12 volt. Okay, and pin number here also we are making the same voltage minus 12 volt. Okay, so here I will write minus 12. Okay, so here you can see here there is a 12 volt, here there is a minus 12 volt. Okay. Now one voltage probe I will connect to the input side. Okay, and one voltage probe I will connect at the output side. Okay, so I will connect the another voltage probe at the output side. So consider that here I am taking a here. Okay, at the output side. And if you want to just okay, so it will be more clear to you. Okay, so we have connected at the input side. One is we have connected at the output side. Okay, so here you can give a name, change a name. Let us we will give a name. Instead of PR1, I will give a V in. Okay. And here instead of PR2, let us I will give a name B out. Okay. Oh, okay, now we want to do the simulation for this. Now start time. Okay, so we want to do a simulation. So we will do a simulation transient. Okay, and start time 0 and end time we will keep a somewhat larger 15. Okay, and now let me run the simulation. Okay, so now let me run this. So I will run the simulation. So see, you can see the waveform. Yes or no? Is it done? Getting? Okay, so again you have to take a V input. Okay, this one is our V input and the voltage is amplified. See, this is the maximum voltage. Okay, so you have to take a different reading of V input and V output and find out the gain. Okay, so I hope that everyone has understand. Okay, so now quickly write down your enrollment number in a chat box. Okay, so today we have completed 2 practicals. Okay, practical number 8 and 9. Already I told you practical number 11 is the ELCB, working of ELCB. Okay, so already we have done ELCB in the last laboratory offline. Yes or no? Okay, so you have to write down your own. Okay, so now the remaining practical are only 2, that is practical number 10 and 12. Okay, so whenever we are getting a time, I will inform you the schedule. And in a one lab, we will complete these 2 practicals, practical number 10 and 12. So our whole up to 12 practical will be completed. Is it okay? Yes or no? So what you have to do? You have to do this 2 simulation in a multi-sim online. Okay, you have to take a printout of the circuit diagram and the observations, means we can say waveform. Okay, and you have to do the observation table. Okay, so you have to complete this, and how to submit we that I will inform you later on. Okay, but up to the 7 practical already you have submitted in offline. Okay, in a hard copy. Now how to submit the remaining practicals that I will inform you, but complete this practical number 8 and 9. Okay. Thank you all of you. So I hope that everyone has written the enrollment number in a chat box. Or if you still any doubt, you can ask anytime regarding this simulation. Okay, so thank you. Here I'm ending the session. Do the practice of this simulation on a Simulink multi-sim online. Okay, thank you.